Cool. Yeah. So let's see. I think we're just kind of going to do Ethereum mental model from a developer's point of view, and kind of more like a builder, like a product developer's point of view. I'm not a great developer or a great researcher. This is definitely won't be anything to do with deep philosophy of decentralization or anything like that. I'm a lowly builder on Ethereum. So I'll share my screen in a second, but just to cover just some basics, I'm assuming that everybody kind of knows a little bit about Bitcoin and kind of understands how Bitcoin works, probably a little bit of proof of work. We'll get through more of that as we go, but just to kind of, I'm hoping that I don't, I have that knowledge kind of to stack on top of here. But Ethereum is similar to Bitcoin in that it's using proof of work, and it is a similar like ledger, distributed ledger type system where you can send funds to and from accounts. But Ethereum kind of turned it on its head in terms of its purpose. It basically opened its purpose up to anything, right? You talk about Bitcoin being hard money, but Ethereum is more about, it's more of a development platform. It's for smart contracts to be built on top of a decentralized network that's secured with proof of work. So if we, let's see, if we think about Bitcoin and it's kind of like a ledger, you can send money from one account to another account. What Ethereum is going to give you is you can execute, so you can deploy a smart contract and it exists just like another account, another externally owned account, and it can send and receive funds also, and it can also execute data and have storage. And we'll kind of get into that and talk more about it as we go. One thing, let me start out by just sharing my screen and kind of get there we go. Cool. I think that the first part, like the first thing to do, like the very first page, if you don't land, sometimes you just land on ethereum.org here, but you may go to Etherscan. And so Etherscan is just like a disinterested third party, right? Like they're just a website that shows you analytics about Ethereum. And you always want to have like these third parties in a decentralized network, right? You don't ever want to have one centralized controller, and you don't want to go to just one place to get your information. This right here in the background is an Ethereum node. And I can see that it's on what, like block 51. So whatever block that number, but 51, but I can see it over here, and I have a full node running right here, and I can validate any of this data right here on this little machine, right? And you can imagine a whole network of those in a very decentralized way, communicating peer-to-peer, keeping like 25 peers. And then there's also miners on that network that are crunching away at a hash using proof of work to then take a block of transactions and validate them, kind of using the last hash and creating a chain, kind of like a linked list of blocks of transactions. And the deeper you get into those blocks, the more secure it is. And you can kind of fork away. You can have an instance where the network itself can fork. And if you think of it like just not even attack, just a distributed network, right? Machines all over the world. Someone over here mines a block and someone over here mines a block. Just the time that it takes for that block to propagate, there's going to be two chains for like 15 seconds until someone on this chain or someone on this side mines a block. And then all of a sudden this chain's going to be longer and heavier and everyone's going to switch to that one. So you can still get some weird stuff, but with proof of work, you get this decentralized consensus. And I'm kind of assuming that everyone's got most of that down and they understand decentralized consensus. And what we're doing here is watching a mediocre nerd build on top of that decentralized consensus. So let's see. So we've got Etherscan up. You could go to the Ethereum homepage. This is probably another great place to jump in. I usually dive into the developer stuff right away. Another place you can go, I mean, obviously crypto, Twitter, and the internet is great for stuff, but let's see, what do we want? I want MetaMask. So MetaMask is a wallet that will hold your key pairs in a Chrome extension. So instead of you having like a hardware wallet, you can have a Chrome extension that can then talk to websites and you can give it access to certain things. You can send crypto. So I can pull up my MetaMask here and I can say I want to, like send some crypto to austingriffith.eth, right? There I am. Okay. And I'm going to send me let's see, how much money do I have in this account? Like $100, not 100 ETH. That would be cool. That would be cool. Let's see, let's switch this to USD. Look at this UX, isn't it great? 100 USD. So I'm going to send 100 USD to this account. Could be across borders, could be anywhere, right? Like this is what it takes to have an account, and I'll explain it in a little bit, is just a random private key. That's all you have to do to participate in this network. You'll have to get some ETH to pay gas, and we'll talk about that. But here we go. I think I'm going to send $100 to AustinGriffith.eth. Let's see what happens. And it's going to cost me 26 cents in gas. So I'm going to have to basically bid to convince the miners to mine my transaction into the block. And if I don't spend enough, it'll just lay around in a memory pool and never get mined in. But eventually, if I put in enough gas, if I put in the right amount of gas, right, you want to put just enough in, then it gets mined. And there we go. I just sent $100. So cool, good start to a live demo. And what happens is on Ethereum, about every 15 seconds, a block is mined, and we could probably see what block happened back there. But basically we caught a good block and we had a good gas price, and we got our $100 sent really easily. Cool. So sending value is awesome, right? It's cool to have money kind of at the baseline protocol. But what we're going to talk about today is kind of like building and creating smart contracts and whole decentralized applications on top of that layer, and kind of like what's possible with that. And it's something I love very much, and I spend my days building and mentoring other developers. So this is something I really get into. Let's see, where are we? Okay, so I think maybe ETH build. So let's just cover some fundamental concepts. So ETH build is a tool that I've created that at first it was for me to kind of just like explain things. Like when I'm on a mentor session with someone and I need to explain a hash function, I can just pull up ETH build, and I will do that today. But it kind of, as I built through this curriculum, it became a more sophisticated tool. And by the end of it, it gets complicated, and you'll see that when we get in here, but it's still a powerful and a cool tool. It just gets way too complicated too quick. It's great for tinkering. There we go. This is the Byzantine general problem here. So that's how complicated it can get. Let's see, if I zoom in, does this get bigger? Oh, cool, very neat. Okay, so just to get a feel for ETH build, basically you've got these boxes and they've kind of got inputs and outputs. And so this is just a hash function. This is the Kachak 256 hash function. So if I put in hello world, the point is I'm explaining a hash function, as in when we look at this output over here, it's going to randomly lay in some histogram, right? You can kind of watch whether this is, can we do color? We're doing color. Can I just drop it in there? Really? Does it change? Oh, no, it doesn't work at all. That would have been cool. Okay, so you can see that as I type anything in here, we see the output. We see the output of the hash on the other side. So Ethereum concepts. The very, very first thing we want to talk about is a key pair. It starts with a private key. So this guy right here is everything. You do not want to show anyone your private key. It's basically a 64 character hex string. And that provides enough randomness that if you worked as hard as you can with as many machines as you can find, you're never going to guess my private key. It's kind of like I'm probably talking to a bunch of math nerds from Berkeley, but it's kind of like when you shuffle a deck of cards and it's possibly a shuffle that has never happened before. Like I have a hard time wrapping my mind around that. I feel like humans have a hard time wrapping their mind around like the probability of me walking through that wall and the fact that it's still like maybe statistically possible. But anyways, there's enough entropy in this 64 characters that no one's ever going to guess it. So if you come up with a good random one, and we'll just generate a couple of them here with this button, we can just say, okay, that's good enough, that's random. And from that, basically you get a public and a private key, and the, let's see, the public key is hashed to get you your public address. So there we go. We can see kind of the end of this is that right there. I'll probably find it, D4, D9. Yeah, there we go. So there's my address. So private key, don't share it with anyone, keep it. Derived from that is a public key, and derived from that is your address. And that's where people send money to. So just like I was up here where I had that address, I could paste that in down here and it will give me that same, there's that address, B2AC, and it kind of has a little image. And if we go to our disinterested third party Etherscan and ask, what about this address? There it is. There's the $100 we just sent. Very cool. And then if we go look at this guy, no matter what, so I could do this all day for an eternity, generating private keys, grabbing a public address, going into Etherscan and praying there's money there. There's no money there. Okay, so now we've got kind of like the account down, right? You've got your private key, you've got your public address. The private key is basically just generated by you, and as long as it's random enough, you're good to go. So what can we do with this address? How can we participate on this network? So one of the first things that you can do with an address is you don't want to, with a key pair, what you don't want to encrypt and decrypt with a key pair, with an Ethereum key pair, the math nerds out there will correct me on that. There's better curves and better, there's better curves for that, but you can encrypt and decrypt with a Ethereum private key pair, but I would not recommend it. But what is really good is signing and recovering. So what you can do is, let's say we have some message, let's see, text, let's just say it's hello world, and we're gonna plug that into our message here, and then we use our private key. So our private key signs this message, and out of that comes this signature. So let's see, I think if this is live. Yeah, it is. Okay, so hello world, this is live. So I've got my message here and I've got the signature, and I think you can see that signature change as so it's signing it with every keystroke. But basically, I'm taking this message, I'm taking my key pair that I just generated that goes to this address, and I'm signing a message. And with that signature, this can go across a network, right? This could technically go, this could be completely public on some any kind of like IPFS or any kind of publishing, any kind of network. This can go public. You don't care about it. It's okay if your message and your signature is public. It's shared with someone else, and then finally, let's say this is kind of this is on the other side, right? This is somewhere else. Someone can then recover that you signed that message. Given the message and your signature, that they can say, oh, that was that person that signed that message. So this makes us really powerful. It gives us the ability to sort of commit to something with an account and have that commitment be backed by cryptography in a way that other people can see exactly. If we give them the signature and the thing that we signed, they can easily prove that it was us that did that. So that's kind of like step one in this whole thing, is you have a key pair that can sign something. So then if we start thinking about like, well, what if we have like a ledger of, let's see, can I bring a ledger up here? Yeah, okay, so now we're into the 90s, right? We're into the 90s and the cypherpunks are starting to get weird, and they're figuring out distributed ledgers and how we could maybe have a global currency, a currency that wasn't controlled by some government with guns. So the ledger here is a key piece of that, right? And everybody on the network is basically going to have to keep. So we're going to have this big network of people, and they're all going to kind of talk very decentralized. There's no center person. They're all going, what a bad network drawing this is. They're all going to talk kind of peer-to-peer, and they're all going to keep track of their own ledger. And what we'll do is we'll basically bring in an object. Whoa, where's the object? There's an object named object. That's what I want right there. Yeah. So we bring in this object that's like, okay, instead of just a message, what if this message was, an object of a to and a from and a value? And so we could bring this transaction in and add this to our ledger, and everyone on the network would have that same transaction, right? So Bob signs a message and sends it out to everyone on the network, saying I'm sending $1 to Alice. Well, that's there's our first attack vector right there. Is Alice can then replay Bob's message. Oh, put it out on the network again. Or actually, it would be Bob replaying. No, it'd be Bob. Yeah, it'd be Alice replaying this because it's to Alice, right? Ooh, value 10. I think I need to adjust this to not decimals, 0 decimals. There we go, 10. Okay, cool. And then can I get the balance? I probably could get the balance of Alice, but let's just assume it's 10. But what could happen here is Alice could replay that same transaction over and over on the network. And kind of the way I want to go through this and explain Ethereum is kind of talking about these attack vectors. And so this is kind of the first attack vector. Basically, what Bob needs to do is create a nonce, a one-time unique. Oh, what is going on here? A one-time unique. Let's see, there we go. And this will be a nonce of 0. Wait, don't need that. Is he gonna like that? All right, there we go. And then if we require a nonce over here, then, oh, I wonder what's gonna happen here. Let's reload. Going for a refresh. Okay, there we go. So now that 0 goes, but now if I click this again, it's not gonna go anymore, right? So just by providing a unique nonce in that thing that you sign, since you signed it, people could replay it. What you have to do is put a kind of a little nonce in there. And then when they try to replay it, it will only play once, and then your nonce increases. So the next transaction has to be another one. There we go. So now we've got this ledger, we've got this nonce. This system works pretty well. We have an internet, right? A really well-connected set of computers. They all have these private keys. They can share their public keys. They can sign messages saying they want to send value to each other. But things kind of went into a winter mode in crypto land a little bit. And it took until, and it basically was this Byzantine general problem that is a good example of. I'll have to zoom out a little bit. But what we have here, it's basically a coordination problem. So you've got, let's see if I can draw. You've got this city, and then it's like disconnected by mountains and rivers, but then you have these generals that want to attack. And the thing is the city is fortified by just enough troops to basically defend off kind of 1 or 2 attacks at a time. But if everyone attacks at once, then they'll lose. And the key here is you have to communicate you have to send spies through the city. So your communication is basically completely public and can be tampered with. Someone could say they're General Bob and they want to attack at Tuesday. And then you could send attack messages to everyone just right where they would attack one at a time, and you could stop them. So what the attackers need to do is figure out how to coordinate through this method, and the answer turns out to be proof of work. And so what Bob would need to do is prove to the other armies his ability to wage war. I had this really bad analogy of soldiers' toes in wheelbarrows, where you would wheelbarrow over a whole set of soldier toes. The soldiers could still fight; it's just a toe, right? You would prove to the other armies that you have an army and you want to attack. It would be a signed message with toes and your attack plans. But basically, you would prove to the other armies that you wanted to attack. And by putting your attack plans out into that public network with that proof of work, that can't be tampered with and that can't be faked. So the idea of proof of work kind of turns into this hashes, and you've seen Bitcoin. But what we're doing here is we have all of these soldiers, these miners, and let's see what they're doing. So we have General Bob, and we have his attack plans here. But then he has all these soldiers up here. And if I go into one of these soldiers, we can see that he is jamming away as fast as he can, or she, it is jamming away. They are jamming away at trying to find leading zeros. So when I get back over here, we can see that every once in a while, one of these soldiers finds one, passes it up to a lieutenant, passes it up to General Bob, and General Bob has proof of work. And so that was kind of the proof of work revolution that brought about Bitcoin. And you can play with it here on ETH Build. But eventually what we do is we get into blockchain, right? So now that we have this, let's get rid of that drawing. Now that we have this kind of consensus mechanism, and we can start blocking we can start putting these transactions into blocks, then we can kind of we can add that same nonce, that replay nonce. We're going to throw a nonce in here, and we're going to have leading zeros. But basically, you can see this miner is working away at this block, and eventually this miner will find some leading zeros, and that block will be mined, and we'll continue on with mining blocks and transactions getting mined in. Still, hopefully you know all of this stuff and I'm kind of mansplaining it. Let's go to the next thing, which is, well, transactions are here, and you can see how we use a blockchain and an account with an address to sign a transaction. And a transaction consists of a to and a value and your gas to incentivize that miner, but there's also this data field, and we'll get to that in a little bit because I feel like it's like the key thing to make these smart contracts work. So there's your transactions, and the last thing is smart contracts. There we go. So smart contracts. All right, now we're getting into it. Awesome. So let's see. With the smart contract, we can basically write Turing complete code, and that code gets compiled, and that compiled code basically goes out in a transaction as a deployment, and the rest of the network, the miners on the network, see that transaction go, and they say, oh, this is a deployed transaction. So going back to, let's see, give me that transaction thing again. Going back to this transaction, you've got a to and a value, but there's this data field. So this data field goes along with it. Let's go back to, where's our Etherscan? Let's bring another one up. Okay, Etherscan. Let's go find a transaction. So latest block. Let's see, where are the transactions here? 172 transactions in the latest block. Let's just find a random one. Is there any data? There isn't. Darn it. Can I just like click through? Oh man, I should have had a transaction ready. All right. Oh, this one's, there we go. Let's just pick one of these is going to be, there we go. Okay, so check this out. So there's a to, and the to address is this address right here. And the from is this address right here. And the value is $81. They paid $2 in transaction fees, but they're doing this. Let's see, can we view this raw first? There we go. This, but they added this in the data field. So this is what that data field looks like. There's the to, there's the from, there's a value, but there's also this data here. And this data is really interesting because the miners can parse this information and use this to understand what you're trying to do. You're trying to interact with something here. In fact, we can see, let's see, we can see that you're actually calling by new level, whatever the by new level function is on this contract. Let's see if this contract is verified. It is. Cool. Okay, so whoever deployed this contract has uploaded the source code to Ethereum, and we can see it here. That's probably like a scam or something. I don't know. I have no idea what this is. I'm not even going to get into it, but here it is. Here's the smart contract. We can see the code that's actually running here. So what was the function they called? Let's go back to that. It was by new something, by new level. There it is. There it is. And they passed in uint8. And so they pass in two small numbers and they paid some money. And so there's some rules here, and we'll get into that. And then you can see it's just like typical programming, right? If, then, if, else, requires or rules. There's, arrays. Message.sender is a global variable. We'll get into that in a second. But we could see that this person called that function, whatever that did, some kind of state update probably, and it emitted, I can't tell exactly what's going on here. Looks like whatever. What is this? I don't know. I'm not gonna mess with it. I'm not gonna get in and read somebody else's contract. Okay. So the smart contract basically uses this data field. This data field that comes along with this transaction can be just like a message. How I sent myself some money up there with MetaMask, I could have sent that money to myself with a little message like "Hello World" or something like that. Happy Tuesday, right? But since you have the ability to put that message in, if you fire a transaction off and it doesn't have a to address, all of the miners are going to look at your data field because that is how you signify that you're deploying a contract. And they all respect that as, this is a deployed contract. I need to run the constructor. We need to get this set up. This person's paying gas. We're ready to go, right? And then if you send a transaction with that stuff in the data field, that call data, and it's going to a smart contract, then it's going to parse the first 4 bytes and figure out which function to run. And it's going to go run a function on that contract with the arguments that you've supplied. So that data field really is kind of like the crux of all of this within the transaction. So it's, you've got everyone sending each other transactions, but that data field is helping to trigger the miner to run something. And every miner on the network has basically like a little execution environment. It's the EVM, the Ethereum Virtual Machine, and that has let's go to the Ethereum white paper, yellow paper, the Ethereum yellow paper, fantastic. And I'm going to scroll through all the heady nerd math and get to right here. Cool. So these are commands. So these are all the low-level commands and also how much it costs to run those commands. And if we find like an S store, that's 20K. Oh man, it's not actually showing how much it costs. Wait a minute. How about Ethereum white paper? I want to see exactly the gas costs. Oh, Merkle trees are really interesting too. Going back to the hashes, and you'll learn about all this stuff. I saw the curriculum and it's really good. You guys have a good lecture coming up on Friday, Thursday, so you'll get a lot more of this. Let's see where. Come on, give me. Darn it. Okay, so basically every little move that you make within your smart contract is going to cost a little gas, and we'll get to gas limits a little bit later. Actually, let's see gas price. Let me see where I'm getting here. Call data we just covered. All right, now that we've covered kind of ETH build, you can get in here and really there's a bunch of stuff in here, a lot of stuff. So like I don't even what's a good. You can compile contracts. You can bring in a blockchain and you can look at, say, like what block number. So this would be what block the current. So this is what block Ethereum is on. And we can see right there, 6.7. Yep. Okay. So you can get in, let's see, we could send something, right? This would be some kind of signed transaction. You could get the balance for some address, right? I'm not gonna mess with it. Oh, wait, you can bring in your MetaMask, huh? And then I can bring that address, there it is. There we go. And then I could bring that to a balance and call that, and that should give me some kind of a balance. Yeah, look at that. Cool, neat. Okay, so that's ETH build. We've kind of gone through the fundamentals. The real interesting thing there is that key pair and understanding where that key pair is. The key pair is then kind of in MetaMask over here for me. So as a user, I'm basically just going to have MetaMask, and I'm going to go to dApps, decentralized applications, and they will ask me for, let's go to ENS. So ENS is a smart contract that lets you register your name like DNS. And so I could launch the app. It's probably going to ask me to verify my MetaMask. Let's say I want to register austintgriffith.eth. No way is that taken. No way. There we go. Cool. So I could register that basically. And if I hit register, it's going to trigger the extension to say, hey, do you really want to pay this 52 cents to, let's see, do we even see the data? Yeah, cool. That's awesome. Awesome. So there you go. So you've got a website. Your users will have MetaMask if they're elite. If not, they'll have to go download it and get Ethereum. Onboarding is still kind of a tough thing in the ecosystem. We're getting better and better every day. But you can imagine that the applications that you will build on Ethereum, a lot of your users will have MetaMask, and that's how it will work. Basically, they will hit a button in your app and get a pop-up to verify whether or not you want to run that. Let me go cancel that before. It's probably already canceled. Okay, cool. So the next thing I want to kind of transition. Let's see. There's probably chat. I haven't even been paying attention. Oh my gosh. Nope. No questions. Cool. No. Feel free to like drop questions in. I'll just keep the Q&A thing up right here. So feel free to ask any questions. But we're going to transition now kind of from ETH build and all of these resources are here. I'm sure Etherscan is here somewhere, but if we get into Start Experiment, there's ETH Build. There's also Ethereum Studio and Remix. Let's go look at both of those real quick. So Ethereum Studio kind of sets you up with an IDE right here in your browser, and you've got your smart contract here. And where's the compile button? Deploy. You'll have to go learn. There it goes. Look at that. We just deployed. Awesome. Update the message. Let's do it. Now I want to try it. Hello world. What did it do? I don't know. I can see the blocks are incrementing. Let's see. Well, let's see what happens. That form probably calls the update, which sets the message. So how do we query for the value of the message? Wouldn't it be good to have that up right? Okay, anyways, see you later. See you later, Remix. Okay, no, Remix is cool too. Remix is a very similar thing. You've got your smart contracts right in a browser. Remix actually, a lot of people that are kind of like not super nerds that want to set up their own local dev environment, people will just use Remix to deploy straight to mainnet and then build an app around that once they've deployed it here. So you will see people deploy tokens like right from Remix, and you can do that here. Again, though, these are probably more like sandboxes that you can play around with and learn in. And then when you're ready to set up your local environment, lots of great tools. We're kind of at a turning point for Ethereum development where it feels like the tools that are being built with the developer in mind, not just like getting the job done. You know a tool that is built to just kind of like, wow, this like the guy who built this never used this. He just built it and sold it to me. You know what a tool is that's not built for the user. And I think that we're getting to the point where our tools are built for the user and they feel a lot better. I would highlight Biddler, which is actually renamed to Hardhat. Hardhat.io. And what Hardhat, no, that's not it. How about hardhat.dev? Wait, let's just click. I bet it's going to forward us to Hardhat. Why didn't I just do that? Okay, hardhat.org is Biddler, but no one wants to say Biddler. It's like a meme, like the HODL was a meme for Bitcoin and it just meant hold, but Ethereum kind of repurposed that to Biddle. But it's really hard. Biddler, like if you wanted to search the docs, you were just lost because Google was like, "You're misspelling that. Let me give you the right thing." And they've renamed to Hardhat, and they're really, really cool. So it's a way to compile your contracts. It's a task runner. It just does a lot of things for you that you weren't able to do at first. Cool. Yes. Let's talk about oracles also. I think we'll get to oracles. The Oracle problem is an interesting one. I do have it in my notes and we'll tap on it in a second. I think that like there's not a ton of material that I know of to learn about oracles. Like check out Chainlink, check out Reality Keys. There's a couple other Witnet. There's a couple oracles out there. But we'll get to the Oracle problem. Let me get in there a little bit more, and then we'll get to the Oracle problem. So what we want to build is an app. I'm going to use Scaffold ETH. So Scaffold ETH is a GitHub repo that I've put together that you can clone. So I think you can just jump over here now. Yep, there we go. Okay, so I've already set it up. Basically, yarn install everything that you had to do here. So I cloned it. I did a yarn install. So yarn start is this window, and then yarn chain brings up my blockchain, and then a yarn deploy will deploy. Basically, it'll compile my contract, deploy it to my local blockchain, and then take what's called the artifacts, basically the bytecode and the bytecode of the compiled contract, and then the address of where it's deployed, and inject that into the front end. So what I get is this really nice system where I can make decentralized, where I can make a small change to my smart contract and tell it to deploy. And what that's going to do is get that shipped all the way to the front end, and this will hot reload over here, hopefully with, cool, there we go, programming decentralized money. Okay. So this is where we can really start to play with Solidity and see how that works. So Solidity is basically this Turing complete language that compiles down to bytecode. That bytecode then gets shoved into that call data field, that data field in those transactions. And so if we wanted, we can compile. Let's go look at the artifacts. Let's look at the artifacts. Let's see. So I want to, there we go. Whoops. Yeah, there we go. So what I want to see is the bytecode. Nice, there it is. There it is. So for this contract, there is the bytecode. So if we deployed this contract, you know that in Etherscan, when we went and looked at the call data, you would see this basically. You would see that, oh, this person is sending a transaction to no one, and this stuff is in the data field. They're deploying a contract. And by doing that, then all the miners on the network would start to keep track of, let's see, what do we have? We have in our smart contract, we have some string that's a public purpose, I guess, some arbitrary message. And then on constructor, we set that purpose. Actually, I don't want to do that there. And then we call the set purpose. Yeah, I want to set that. Someone's been messing with my master branch. All right, let's see. Let's get that out of there. All right, so let's just do that way. Let's make sure that still deploys. Okay, now, so you've checked out Ethereum on Etherscan. You've learned the fundamentals with eth.build. Now you've got a local development environment up, and you're ready to start tinkering and writing your own smart contracts and decentralized app. Where do you go? How do you find out more? Look at Solidity by example. Google Solidity by example. Look at this one, number 6 right here. It's also, there's a link right in the Scaffold ETH repo. But then I guess you would Google Scaffold ETH and click it. Why not just Google Solidity by example? There it is. Oh, and let's grab those globals and units too. That'll be handy to have also. So once we have this Solidity by example up, we can get in here and be like, okay, what are some primitive data types? I'm a programmer, I get this, right? There's bools, there's going to be ints and uints. The 8 and 256 are a little bit weird, and we'll check those out in a second. There's also this address. This looks like we've already learned what the address is, but it's interesting how this is just there without like quotes around it or anything. And bools, uints, addresses. Okay, so really the two things I want to dive into here is this uint 8 versus uint 256 and this address and how we can talk to it. So if we just, well, first of all, let's just talk to our contract and make sure our environment is set up. So if we say hello world and we send that, oh, we don't have any gas. Okay, so first of all, we've got to copy our account here. And there we go. Okay. So what has happened there is this account, this D75B, is actually generated for us on page load. So instead of having MetaMask, we can use MetaMask, right? I can connect my MetaMask. There's that BAC. Oh, it's Austin.nifty. That's a nice ENS resolve. That's this account right here. But I'm not going to use that. Basically, with Scaffold ETH, it creates what's called a burner wallet for you. And that burner wallet is basically a private key and local storage. So don't put a lot of money in that because your local storage is very ephemeral. But if we have a private key and local storage, it allows us to interact with things and sign messages and do all that without that MetaMask pop-up going on. So what we're doing is with this D75B, we're basically signing a message that says, I want to call the set purpose function on this smart contract that was deployed to here, and I want to pass the argument blockchain, and I hit send, and there goes that transaction. And for longtime developers, you'll laugh at this, but we just got console logs. So you can finally do something like a console log right here. Thanks to Nomic Labs and Hardhat, you can do a console log here and actually see what's going on within your smart contract. Debugging the EVM is quite a challenge. So we can also kind of like work on the mental model here. Now that we're saving, we're doing a save to the blockchain. That's like that it costs that account some money, right? And to think about this, like if you're a developer, if you're a coder, you can kind of think about Ethereum like a very, very, very expensive database, very expensive, very slow database, where when we do that right, basically we're putting a transaction that has to get mined into the network, and then all the miners on the network that keep track of our little smart contract have to update that value to blockchain. So you can see that it's very expensive to get that all out there to all the miners, to keep them basically economically incentivized to do all that. They get block rewards for each block they mine too. But the reads are really, really cheap, right? If we're talking about reads and writes in database, writes are very expensive. They take some time, but reads are basically from anyone on the network, right? Going back to that really bad network drawing I did earlier, any of those nodes on the network basically hold this guy right here holds the entire state of Ethereum, and you can ask him who anybody's balance is or what some contract value is right there. And that's like, it's like a $200 machine or something. It's not fancy. Okay, so let's see. We have stored some value. Let's look at that uint8 real quick. I think there was a question. Is there a difference between bytecode and deployed? Actually, I don't. Yes, there is, and I don't know exactly what it is. Maybe it's optimization. When we were looking at that file, let's go back to that file. Where was that? There was definitely a difference between bytecode and deployed bytecode, and I cannot answer what that is. I'm guessing optimization or like deploy arguments, maybe. There is like a tiny difference there though, right? This one ends. Can we see the end of this one? That is a question. Oh, it's right there. Yeah, I bet that is like a constructor argument or something. That is a question that Google will answer for you in a second. I'm sorry, I should be able to answer that question. I could Google it, but I'm guessing that that's a deploy argument, that thing on the end. But then why was this deployed one smaller than the, okay, here's my guess. I'm guessing optimization, right? Because the deployed one was smaller. Maybe, I don't know. Google it. We'll answer it. There's some kind of optimization that goes into there. Plus, there's deployment arguments. I'm not exactly sure what the difference between those two is. Okay, so let's look at that uint8. Let's the point of Scaffold ETH is to get in here and kind of play around. So let's just make a public counter. Let's set it equal to 1. There we go. This is like super simple programming here, but we're going to create a decrement function in this nice Turing complete language, and we're going to tell our counter to equal counter -1. And this is super simple, super stupid code, right? But if you think about what's going on here, we're going to deploy this contract to like a network of tens of thousands of miners, and they're all going to keep track of our count for us. And even if like half the world was destroyed, the other half would still be there and still be in consensus and working. And if we ever wanted to ask what the value of our counter was, we could ask any of them and they would all have a copy of it. And so we could ask all of them. We can ask a bunch of them, right? But writing it is going to be more expensive because we have to get it mined into the block. Okay, here's what's going to happen. All right, here we go. It's a uint8, right? So it's using 8 bits to store this counter, this number, right? uint8 counter, and we're going to decrement it by 1, and it goes to 0. But what's going to happen when we decrement it again? Oh, underflow, right? So you have to be kind of aware of what you're doing when you're writing smart contracts. It's really easy to get in here and write some Solidity and play around. It's really, really easy to build a decentralized application prototype. And I build them like once a week, but it's very, very, very hard to build a secure smart contract, to build a secure decentralized application. And you really have to have an adversarial mindset when you're getting in here and building these things. So there we go. This guy figures out how to underflow our counter. And if this was a token balance, they would basically have like infinity money, right? And if we make that, so just to play around with the 8 versus the 256, what happens when we use 256 bits to store our number? Well, we get a lot bigger storage space. Let's see what that thing looks like when we underflow it, right? It's gonna be a big old number. Boop. Boop, there we go. Awesome. So there is the biggest possible number you can store on Ethereum. And in fact, You would not want to try to store that in JavaScript because it would fall apart. That's another kind of gotcha as a programmer. You have to basically keep track of your numbers in these objects called big numbers and sort of do your math as these big number objects. And then finally, right before you display it, you kind of flip it into a decimal or whatever. Okay, so let's see. Let's look at the address data type real quick too. So let's say this purpose that we're setting here, we wanted to make sure that, let's set an owner, right? So let's do address public owner, and we'll just set it equal to this guy, and we'll hit go. So now there's going to be this new data storage in our contract that's an address type. And an address type is kind of a neat data type because it can do more than just what you would typically think. You can actually call things on it. So there we go. We're the owner, right? And so what we could do is we could do things like if owner.balance is greater than 0, then do something, right? We could write some code that looks at the owner's balance, or we could say, you know, like owner.transfer some money or something like that. So these if it was a smart contract, if this address went to, watch this. So if it's this smart contract, this Olga, we could go, okay, this contract, we're going to go owner.set purpose, right? You could, or a call, basically you would do a .call and you would tell it that you wanted to call a set purpose function. You'd put the call data in there, but that then like contract to contracts can talk, and it gets really interesting how that works. But what I want to do here is, let's see. So I'm going to set me as the owner real quick. What I want to do is only allow me to update this. Yeah, that's right. This purpose. Okay, here's what we're going to do. So what we're going to do is we're going to create a require statement. And a require statement, if you're a Node programmer, you're thinking like, oh, I'm importing something. You're not importing something. It's like, think of it more like assert. You're basically making sure some condition is set. So the condition we're going to check is message.sender equals owner, and we'll say not the owner if that happens that way. So this message.sender we've kind of brought in here, and I haven't really talked very much through that, but that second link that I had is units and globals. And we can see down here, message.sender, sender of the message. That's not very descriptive. Message.sender is basically the person that's calling this function. Whoever is triggering this, whoever has basically signed that transaction and sent it in is the message.sender. And technically can bounce around, and there's a tx.origin, and that's actually the sender of the transaction. The message.sender is the last hop. So if you had like a smart contract, so if you were calling a smart contract and the smart contract was calling another smart contract, let's call them A and B, the message.sender in B would be A, and the message.sender in A would be your external account. Woo, too much information. I already know it. I already know that's too much information. Okay, so here we go. What we're gonna do is we're gonna write a rule, and we're gonna make sure only our address, so only the person that controls that private key that derives this public address is going to be able to set the purpose now. And by setting these rules, it becomes a lot more powerful. We can do a lot more interesting things within our smart contracts. Let's make sure this is deployed. Okay, so how do we test this? Basically, we want to go probably happy path, sad path. So we'll grab, let's see. Whoa, what? There we go. There we go. We'll grab this one, but then I'm going to do incognito. He's going incognito. Okay, there we go. Incognito. We're going to bring up localhost 3000. There we go. So now, look at that. I got 2 addresses, right? Give this guy some. Oh, this is cool. Let's actually copy his address. Let's pull up this guy's wallet, paste in $1, send it. Cool. Now this guy has $1. So now he wants to try to set hello world, send not the owner. And then if we go over here, I am the owner, and I hit send, biggity bam, we set our purpose. So that's really not that cool though, because it's pretty centralized, right? Like, why do all this work to create this decentralized smart contract? I guess you could do this if this was some important string that you wanted to be censorship resistant. This certainly would be a good pattern, but I try to tell all the people that I mentor that you want to think of Ethereum like the greatest massive multiplayer RPG that's ever been created, right? You want to think of this as a very distributed, very decentralized, massive multiplayer kind of thing. And so what we do here is we're gonna instead of require the message.sender, we're gonna require that the message.value is greater than, let's see. And here's where we get to talk about the difference between ETH and WEI. So I'm going to say 0.001 Ether. Ether would be our, our amount of ETH that we're going to send, and we're going to say not enough. Cool. And now the one last thing: smart contracts are very safe. They'll revert. If I try to send money, let's do it. Let's grab. Here's the contract address. If I try to just go to the faucet and send that thing some money, it's going to say no. You are not. Basically, you're not allowed to do that. This smart contract will not accept value if you send it to it. There are tricks, but technically it's not gonna, it's gonna try to revert if you send it money, unless you explicitly say, I want this smart contract to accept money. And by doing that, we're going to be able to set it up so anyone can change the purpose, anyone can update the state of this contract, but they have to pay some money. And that's going to be a lot more interesting of an app, because now this guy, there we go. So now he can say, okay, I can, right? And he's going to have to pay 0.001. Okay, this is where we're going to talk about the difference between ETH versus WEI. So if I were to go, let's see. Things are in my way here. There we go. Grab this guy, grab this guy. So ETH versus WEI is really interesting, and this kind of shows it. So you don't have floating points. Basically, think of this EVM, this little machine. This machine is simplified, right? We want the EVM to be simple. We want this thing that all these people have to execute to not have to have floating point numbers, because that's a pain in the butt. So basically, you just have to multiply by 10 to the 18. So 1 Ether is basically 10 to the 18 WEI, and 1 WEI is the smallest amount you can have. So you can do decimals using that system, but when you send it to the blockchain, you basically have to put it into WEI. So that's the actual value. And technically, if we were looking at our smart contract, we could have put this in there like that, and that would be fine. But you can imagine that 1 extra 0 there, whoo, we'd totally miss it, right? But 1 extra 0 here, we're going to see it right away. So humans, they're probably going to want to see it in decimal form, but once it goes to a machine, you need to put it in WEI. Awesome. So there we go. This guy was able to pay to update the purpose in this random arbitrary smart contract that we were playing around with. And he was able to pay some money, but something really neat happened. Check this out. The address, this contract's address now has money in it, right? Oh, wait a minute. It's like a vending machine, right? We created a vending machine in the sky that people can pay money for to update the purpose for some reason. But this goes back to that whole, like, it's a massive multiplayer game, and all these externally owned accounts just generate a private key and can interact with it. But also your smart contracts themselves have addresses, and they participate in this massive multiplayer game. So here, this contract has money in it, and he can send money around, but actually we didn't write anything into our contract. So that money is stuck forever, right? There's no way to ever get that money out. One point to like show here is we could probably just find some stuck money somewhere. Let's go to like the DAI contract on Etherscan. Oh, there it was right there. How much money is locked in the DAI contract on Etherscan? So if a smart oh, I'm way off here. If a smart contract receive, it's all Blockscat. I want. There we go. If a smart contract doesn't have some function to say, oh man, you sent me all these tokens that I don't know what to do with. If a smart contract doesn't have the function to send that out, and it really shouldn't, right? If you go look at a smart contract and there's an address that can move the money, then it's totally centralized, and you've lost your decentralization. What you want is a smart contract that either takes a whole bunch of votes or doesn't ever at all move those things. And so that's what we find a lot, is that it doesn't ever at all, and people will still send value into it. I'm not seeing where there's, let's see, how do we check? What would we want to check? Check the balance of this dude, maybe? Is that right? Well, what we want to do is probably check the DAI balance of this there we go. Yeah, let's check the DAI balance of this contract, and we'll see how much DAI people have sent. DAI is a stable coin sent into this contract. Okay, this is where we need ETH build. We need to take that from Wei to ETH, right? So we're gonna go that. We're gonna say this is a number that we're talking about, and I'm just gonna double click this, and it's gonna go, oh, that's it. Oh, $56,000. So that's, I mean, that's a lot of money. That's a lot of money, but it's not like millions of dollars. So yeah, there's $56,000 locked in this contract because people accidentally sent this token to it, and there's no withdraw function. So let's create our own quick little withdraw function. Basically, I'm not even gonna, yeah, let's do that real quick. It's kind of like a stretch to even, we're writing code. We don't even need to be writing code. I'm not even going to worry about it. Basically, I could create a withdraw function that says, if the owner is me, then you can withdraw funds. And what you would do is you would do something like owner.transfer the balance of this contract to that owner, and it would withdraw the funds. So that is how Scaffold ETH basically kind of lets you play around with Solidity, lets you use the tooling, lets you kind of like deploy smart contracts quickly, locally. But for the last little piece here, let's maybe deploy this thing to another network. Let's see, paying, yeah. So what do we charge? 0.001. Okay, let's write some example UI real quick. Actually, I think it's probably set. So as you get to you get through your Solidity and you get a lot of get your heady smart contract ready to go. Now it's time to kind of build some UI to talk to that. I don't think this is going to work because I think it's going to, yeah, you don't have enough money. Let's set that purpose. Actually, what if I go down here? Oh, set purpose to cheers. Nope. Not enough. So there we go. Send value. Nope, not that one. It's this one. It's gonna be this one. Set purpose with value. There it is. All right, we just set the purpose. Okay, so set purpose with value. Let's see here. So what I've done is I've created all these buttons. There's a bunch of UI elements here, and I've wired them up to do certain things. You can see how this is calling the set purpose function on your contract, but it's not sending any value. This one is basically just sending value. And then we've got the Goldilocks one right here that is both updating, doing a set purpose and sending value. So that button right there is basically what we want for our UI. I'm just gonna steal that. Can I do this? Can I just move this over to our front page route right here and hit save? All right, then we got, oh, what? Oh, this guy doesn't have any money. Okay, there we go. Send him some funds. And then when he says hello, let's set it back to, I want to see the button. There we go. So then if someone hits this button, it's going to pay, and it's going to update the purpose to paying for this one. Okay, cool. Our app is ready to go. We're going to deploy this thing. Okay, so within Biddler, we have this auto deploy that's happening right now. And basically, we want to point that thing at a public network. So all of this is basically happening locally. We're talking to our own local blockchain here. What we want to do is deploy this to some public network. So what I'm going to do is get to, let's see, where is it? Here, the Biddler config. I'm going to point it at XDAI. It's sort of the side chain we were using with that instant wallet earlier. And then I'm going to do a yarn generate, which is going to make a private key for me. And it's going to keep it right here. Hopefully it's not, could be exposed. I don't think it is. Then I'm going to do a yarn account, and that's going to generate a public address or that's going to get my public address for that private key. So then I can use my instant wallet. And I'm going to hit send. And there we go. It's the Scaffold, same Scaffold ETH UI we've seen. It's just a wallet, instantwallet.io built with Scaffold ETH. Let's see if I can, send this guy 0. Let's see, how much? 0.5. Wait, how much does he need? It's going to cost, that's 50 cents is way more than enough. Okay, so now he has 50 cents. He should be able to, as soon as that goes, yarn run deploy. So now it's going to compile our contract, but instead of shipping it locally, you cannot deploy a contract that, let's see, we can take care of all this stuff. There we go. it's got to be able to compile. There's probably like the one. There we go. Okay, now we're compiling. Now we're deploying. So it takes a little bit longer, right? It didn't deploy right away. It's got to wait for the block to get mined. So we've basically put the transaction into the mempool. Hooray! Our block got mined. So this is over on a side chain. So we'll go to Block Scout and we'll paste in this address. Oh yeah, there we go. So we have the address right here. I could copy it right in our app. And while we're waiting, I'm going to do a yarn build and get that started too. But if I paste in that address that we just deployed to, let's see what happens here. Yes, there's our contract, right? So we can go to a disinterested third party. We can say, I think I just deployed this contract, and they can say, sure enough, you did. We could even send in our code and get it verified. What they're going to see right now is just the bytecode. There's the bytecode for the contract. But what we could do is say, here's the source code that I used to deploy to get this bytecode. I'll send it to Block Scout. They'll compile it themselves. They'll prove that that's right. And then they'll post the source code up here for anyone to see. And that makes it just a lot more auditable and a lot more public and a lot more credible when you have your code verified right there in the Block Explorer. Okay, so we need to do one quick thing. Our app.jsx, we sort of like pointed the deploy up to XDAI. We need to point the app at XDAI now too. So if we go to our app.jsx and we get in here and we say, let's see, I think I kind of have a quick, let's see, that one, and we need that one, and the gas price on XDAI is actually just the price of XDAI is just $1, and the gas price is 1 billion. Okay, there we go. Now let's see. Something should happen over here. Our app should now. There we go. Okay, so now our app. It was hard to see, but basically now we have a value here. It's actually reading from the blockchain this value, and if we say hello world here, and we actually, oh, we're gonna have to send this guy some money. Let's see there. Nope, not scan. I mean, I could. Let's receive. There we go. I got to send this guy some money too, right? Because this is a real network where you have to pay funds. So boop, send this guy like 2 cents. 2 cents. That's all. All right. And in 5 seconds, he should probably have 2 cents. Come on. There it is. Okay, now he can pay the 0.001 since XDAI is like a copy of Ethereum, so it's going to be a lot cheaper. And we're going to pay 0.001, so 1/10 of a penny. And oh, what? Oh, I did the thing where I didn't do this. So obviously, if you're building an app, you wouldn't have like forced your users to do that. But this is like for developers, it's kind of scaffolding for developers. So now, let's see what happens. Now we've signed a transaction saying that this contract, we'd like to set it to hello world, and it was mined into the block, and hello world, we updated it publicly. Okay, so the other side of this is deploying. We've deployed our contract. Now we want to deploy our app. So I did a yarn build just now. Now I'm going to do a yarn surge. Okay, and let's see, let's do something. Let's see, Burke block, Burke. Let's just do Burke. Will it let me do it? Oh yeah, no one has Burke.surge. Okay, so now anyone out there, any of you should be able to go to Burke.surge and see the app that we've just built here. And really there's nothing there. And if you have XDAI, you could send yourself some XDAI to this address, and then you could update this purpose. Oh, it's weird. It's not, looks like it's not getting a value. I wonder, uh-oh. Why is it not reading our, hello? Let's see. Let's see, something, it looks like maybe the RPC is down or something. Wait. Interesting. I wonder what's going on there. I'm not even sure what is going on there. Huh. Let me see if I can send. I don't think this is going to work because it doesn't seem like it's reading from the chain. Weird. Huh. Not sure what that is. But technically, we should be able to. I wonder why this isn't reading. Oh, what? Wait, 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 no, 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 something's wrong. It's still reading. Okay, something didn't happen right. We need to rebuild. It's still reading for our local chain. Did you see that? When I was doing this over here, it's trying to read. So it's trying to get the contract that's on XDAI and reading it locally. So we need to just run this yarn build one more time. Okay, we're probably close to closing time. I don't see a lot of questions. I was thinking I would talk about attacks real quick to kind of finish off the talk and then maybe show a couple apps or something. So again, if we go back to, while this is building, if we go back to Solidity by example, and really if you just search for like Solidity exploits, there's so many fascinating things, but Solidity by example, and let's get in here and let's see, oh, if I could spell it. Solidity by example, we'll go to 6. We'll go to what we're looking at is hacks. So there's a handful of really interesting hacks that have happened here. I think that the replay attack we already talked about. The next one would be like front running. Is front running here? Yes. Okay. So front running is basically so front running goes back to like investments, right? Like if some dude if someone said, you know, I want to buy 100 shares of something, and then he would know that the price is going to go up. So he would put his in first, and then the 100 shares would get bought, and then he would sell his and make some money. Front running is similar to that, where basically the miner, basically when you craft that transaction, it's all public, right? And it lands in the mempool, and oh man, my cat's scratching at things. Oh man, it lands in the mempool, and you've got that transaction there. Everyone can see it. And if a miner is smart, it might even take your transaction and say like, well, what if I run this information? And he could just try it, right? And see what happens. And if it happens to result in that miner making money, then they're going to take your transaction, they're going to run the same thing, and they're going to up the gas, and they're going to get paid for it. Or if they're watching you trade on some DEX, like some automatic market maker, they can see that you're about to make a big buy, and they can get their buy in first or their sell in first, and then buy or sell kind of around that. They'll sort of straddle your transaction and make money off the slippage. Okay, so that's another attack that you have to be aware of, is your transactions are public before they get mined into the block, and if you're not safe, they can be front run. Let's see what else. Denial of service is interesting. Like if you can find a way to lock up a contract, figure out how to get it into a state where no one can access it anymore, that's a denial of service. It's a lot more rare because it kind of has to do with how you build your little state machine, and if you don't build it correctly. Randomness is probably something obvious, and this is where we can bring in the Oracle. Everything that happens in that little EVM, in that little execution environment that all the miners have, it's completely deterministic. It runs exactly the same on every miner. So getting something like randomness, or getting something like the temperature in Colorado, requires some external source to sort of write that in. And if that external source is just some centralized service pushing it in, then kind of no matter how decentralized things are in your smart contracts, it kind of falls apart. Your security model falls apart if one script can just stop working and everything falls apart. So you have to think about, Ethereum is good for doing these deterministic type things, having calculation that happens, and everyone does the exact same calculation, and within that, Turing complete execution, it does exactly what it's supposed to do. It's sort of bad at, I want to make a game and I want to have random things flying around, right? You don't want to track a movement because that's going to be expensive. Randomness has to come from some kind of an oracle, so you have to trust some service. So that service needs to be as decentralized as possible. I think that there was a question about learning more about oracles. Check out Chainlink. I think Chainlink is like the major oracle, but it's just a fun problem to learn more about. Same with randomness. With randomness, you can use an oracle. There's a way to do it where it's called commit reveal. So like I would come up with a secret, and then I would hash that secret, and I would put that hash on chain. first. And then at a later block, I would reveal it. And the reveal would then be hashed with the block hash, something that only the miner could come up with after I came up with my secret. So in a way, you can kind of give the user their own confidence that as long as they're not the miner also and manipulating things, that like they can be safe enough that their little commit reveal gave them a random enough number and miners aren't manipulating that. But it's pretty clunky, first of all, 2 transactions, but it just kind of illustrates how randomness is hard on Ethereum. So 2 more attacks that are really interesting. One would be reentrance, and reentrance is how the DAO hack happened. So let's say back in our smart contract, we were doing something like checking, let's see, let's say we have this bool that's called, withdrawn, right? And we withdraw and it's false right now, right? And so what we want to say is, if you haven't withdrawn, right, we'll transfer you some money, right? And if you have with or else, yeah. So basically, you would fail if not, right? Or else revert, right? Something like that. Not the right syntax here, just some, but if we do this, so basically we say if W, then we transfer, and then we set W to equals to true, right? Tur. So now if withdrawn is true, then you can't get back in here again and transfer it, right? So within the execution of the contract, that happens atomically, and we'll get to atomicity in a second with flash loans, but this happens atomically where it either all works or it reverts. But what's interesting here is this transfer could actually go to another smart contract, and that other smart contract could call set purpose again, and the withdrawal would happen again and again and again and again. You can create this loop where you re-enter in the transfer. So let's say the transfer goes, instead of to an externally owned account, it goes to a smart contract, and that smart contract is built in a way where it triggers when someone transfers something to us to come back here and call this again. So you can craft an attacker contract that will basically call the function over and over again, just right. So the fix to this is easy. You basically have to put the W equals true up here, right? So we check to make sure that W is false, we set W to true, and then we do our transfer. And that prevents him, if this contract re-enters again, it's going to be true and it's not going to work, right? But the problem is, if this was some number, like we were keeping track of some amount and we were checking to see if like, let's just say the amount, right? Let's just say we're tracking an amount. Oops. We're tracking an amount, and whatever the amount we're tracking, we basically transfer that amount to someone. So, and then, oh, there's my cat, I'm sorry. And then we'll set our amount to 0 here, right? Because we need the amount to send it. So what you have to do is basically create a temporary variable. This is where people got caught. They didn't create this temporary variable, set to amount, then set amount to 0, and then go ahead and do your transfer of temp, right? Does that make sense? That makes sense? All right, let me get my cat. I'm sorry. Get out of here. Okay, so that is reentrance. Okay, and that's how the DAO hack happened. Millions of dollars gone. The next kind of like the last, latest, really cool, interesting hack is called flash loans. So a flash loan takes advantage of this atomicity of a contract execution. So just to cover that one more time, if we set like A equal to 1, and then we set B equal to 2, and then something bad happens and we revert, it rolls everything back. It's atomic. It either all works or it all fails. So this revert's going to cause B to get set back to whatever it was and A to get set back to whatever it was. So the transaction either all works or all fails. So there's a way, so as decentralized finance has gotten more and more complex, you can now take a loan out, right? So, and that was, I mean, that functionality's been around for probably years, but basically you can put in some money and take out, you can put in some collateral and take out a loan, or you can take out what's called a flash loan, which basically says there's money in this contract. we'll loan it to you in a single transaction as long as you return it in that transaction plus some fees. So we borrow $25 million, okay? And then we can do whatever the heck we want right in here as long as we return, 25, 25 point, let's do it like this, right? Something like that, million, right? Okay, boy, that's ugly. But you get my point here, right? We can borrow some money as long as we return it atomically. So what can we do inside of here? Well, what they'll do is let's take 10 million of this and let's dump it on some exchange that has a price curve that 10 million will shift that curve, and the price of that token will change because of that $10 million, right? So let's see. So what are we going to do? We're going to put the $10 million in to the exchange. Then we're going to go over to some other exchange and probably buy it at a premium, right? We'll buy it cheaper, right? Buy it cheaper. Then we'll get back our 10 million from the exchange or something. And I am not a genius. There are much smarter people that can explain this. But basically, we get back our $10 million and we sell for more expensive, something like this, right? More expensive. We pay back our 25 million with a premium, and within one single transaction, we've made $500,000 or something crazy like that. And technically, the system is working exactly like it's supposed to be. But yeah, you don't really want to lose that money in a single flash loan transaction. So heads up on flash loans. Another really cool thing to explore. A couple minutes left. I can just kind of like give you a lay of the land of Ethereum real quick. So we already talked about MetaMask. Check out MetaMask. It's basically a Chrome extension that is a wallet on your phone. Here, let me put it in here so you can see it. Argent is another, is it argent.com? I feel like I don't want to go to argent.com. Let's just do Argent Ethereum. That is not it. That is the one I want, argent.xyz. So Argent has done a really cool job of creating smart contracts wallets for people. So one problem is if I lose this private key, all that money is gone forever. And it's really bad UX that I have to even think about the fact that that could happen, right? So what I want to be able to have is I want my Argent wallet here, and what I have is a smart contract that's deployed on my behalf, and I can send money to that smart contract, and then I have a signer here on my phone. But if anything bad happens, I have other recovery accounts that can trigger basically a reset and get my money back. So there's, and plus Argent, it's so cool. Get an Argent wallet. You should already be on Argent on your phone already. But I can do really cool things like hit this invest button, and I can go to Aave or Compound or Uniswap. Let's go to Aave, and like I can take out a loan. I can borrow some tokens. Ooh, shorting a token. This is kind of tricky. So basically the first big app on Ethereum is like these ERC20 tokens. Anyone can create a currency by deploying a smart contract that is basically this. Like that's it. I'm going to import that in from OpenZeppelin. We should go check out OpenZeppelin. Basically, OpenZeppelin has created, oh man, I'm all over the place here at the end trying to cram stuff in. OpenZeppelin has created a bunch of really well audited contracts. They've spent a lot of times and put a lot of eyeballs on these contracts. And one of the first killer apps of Ethereum was basically an ERC20 token. And it's super, super simple. It's basically we keep track of a balance, and there's a function that lets you transfer that, and a function that lets you check the balance, right? So it's basically just keeping track of a balance and letting people transfer, and it's that code. And that makes up what a token is. There's some other little things like delegating and stuff, but basically you can issue your own currency on Ethereum with that many lines of code. And Let's see, where were we? We were talking about loans. Oh, shorting a token. I don't know why I went there, but basically what you could do is, okay, so someone's selling their token. It's on an AMM, which is an automatic market maker, which keeps reserves of both tokens or ETH in a token. And when you take a little bit of this one, you put a little bit of this one in. When you put a little bit in this one, you can get some of this out. It basically stays balanced using a function. So going back to our flash loan, we kind of jammed that function over to make money there. But with a token, you can basically borrow a token and sell it, and then later on buy it back. So with borrowing and buying and selling, you can sort of short a token, right? Like I could borrow a whole bunch, sell it, then go borrow some more. You could leverage up on that. And that's what a lot of these DeFi protocols are sort of based on, is that leverage. And then it gets to liquidity mining, which is sort of like, so going back to the AMA, we have the reserves on both AMM, automatic market maker, not AMA. So you've got reserves on both sides. What's hard to do is basically when you're trading between those two pairs, there's always going to be a little bit of slippage because there's not enough reserves, and the smaller the reserves, the more slippage. So you're gonna lose a little bit just to the formula, basically. Also, you're losing a little bit in fees, which is cool. If you see one of those AMMs and you just move money back and forth slowly and slowly, the actual contract balance grows, and the people who have provided that liquidity earn these fees. But that's really not enough to incentivize sometimes. So what they did was create this idea of liquidity providers, liquidity provider mining, where if you're providing liquidity, they're going to give you an extra token that has some other value. Let's see, we've got ENS we already talked about. There's prediction markets like Gnosis or Augur. Those are really cool right now. Basically, there's two, who's going to win the US presidency. You can buy a token, and then some oracle will tell you later on which one was right. And basically, it's like a way to have people have skin in the game, signaling which way they think, because they're basically buying, like, I think this guy's going to win, so I'm going to buy a bunch. And then if he wins, then I win the money from the people who are wrong, right? So you create this market, you put money on the line, and you let people buy and sell from that market. It predicts pretty well what's going to happen, which is really cool. And that's a prediction market. Collectibles like OpenSea, there's a different NFT, there's a different token on these Open Zeppelin contracts called NFTs. Let's see, where are they? Tokens, ERC 721. And these are non-fungible. So fungible tokens, 10 of them are equal to 10 of them. You can swap them around and never know which one is which. Fungible means they're going to have these unique properties. Some of the first non-fungible tokens were CryptoKitties. They kind of had these genes, and you could breed them. But a fungible token is like a collectible, and we can see all these really cool collectibles on here. There's a big market for it, really neat stuff. Digital tokens, provably rare. Nifty Inc. is one that we made that's built with Scaffold ETH. Good night. And it's also these paintings right here are Nifty Inks. But Nifty Inc. is a platform where you can get in and you can do a little doodle. It uploads to IPFS. And then oh man, we got some, there we go. It uploads to IPFS. That's in IPFS. No one can stop. I mean, like, I guess someone could shut down my front end website, but it's just shutting down our front end website, right? That's on the blockchain forever. So you can buy and sell these works on this side chain, and then it backs to Ethereum. But these collectibles, that's the one that I have right there. And I think he's selling it for like $9,000. So I probably shouldn't display it like I own it, because I'm not paying $9,000 for that. Okay, so tokens, we got ERC 721s, we've got wallets, insurance. Insurance is Nexus Mutual and Open. There's a couple other ones. Basically, they set up insurance on smart contracts, sort of like, you can tell deterministically if this smart contract got drained, and then if it did, you could get paid some premium. And really, it's built so, I mean, the smart contract is going to do exactly what it's told to do. So you're basically taking out insurance on something human error, right? Like this whole idea of flash loans is scary, right? And if someone who was building a contract wasn't even thinking about flash loans, wasn't even thinking like atomically people can adjust that price, then you could run into problems with that. So people are taking out insurance against that. Another way to do it is take out an option on a token price. So you could buy basically this option. You pay some money to have the option to sell your token at a certain price. So if it ever goes below that, you could always sell that token with those options at that lower price. So insurance, social networks like Peepeth and Akasha, games, CryptoKitties, check out Skyweaver. Let's check it out. Weaver, and I mean, there's a ton. Is it going to be, why do I keep doing .com? Why don't I just do Skyweaver Ethereum? Is like a cool trading card collectible game, and they focused on user experience. Lots of great games. They kind of started out on Ethereum. They were kind of let's see, Axie Infinity, right? They were kind of like enter through the gift shop, like, hey, we have tokens and this is a craze right now, so you can just get in and buy these things. But there wasn't really any game to it. Now we're finally getting some really cool games. Some AAA players are coming in, some indie builders are coming in. A lot of cool things that you can do on Ethereum. In terms of games, dexes, we already talked about. AMMs, basically the curve where you can trade on the curve instead of having like a centralized order book where you have to trust some centralized exchange. You can now use this idea of these reserves on this function to buy and sell. And then DeFi has gotten pretty weird in the last 6 months or so, but it all revolves around sort of you can put in some collateral and get out a loan. Maybe that collateral goes in to create a loan of a stable coin, and now you have a stable coin like DAI, so everything's worth $1 instead of this fluctuating ETH, and that's a lot better for UX. But then once you have a stable coin, you can do all sorts of neat things on top of that. And so lending and leverage, and then like synthetics with derivative trading. Again, they focused on good UX. A lot of these groups that like focused on great UX and focused on the user have become quite successful. Impermanent loss. So like if you have an AMM and you've put reserves in, and one of those tokens just goes way south or way north, you basically are still left with the same ratio of the tokens at the value. So if this token moons, then you're going to end up with not as much of this token because it's not as big in terms of the weight, like keeping things balanced. So there are these new kind of things that have popped up out of this that are interesting. Let's see. What final weird things, maybe like Clovers.network, pretty cool, by my buddy Billy. It's like doing this kind of mining process where it's looking for these, and it's basically you're mining these collectibles, really kind of neat stuff. Decentraland or Crypto Voxels, it's like a 3D world. Obviously movement's not tracked on chain, but collectibles and coins, and I think even like paint within the system is tracked on chain. There's a lot of things on chain, but movement isn't, but it's still like a 3D world where you can interact and buy things that have real tokenized value. Yes, awesome. I think, yes, looks like we're probably at time. What tools would I recommend if you were going to build your first dApp? So I would go back to ethereum.org, right here. This is where I would go. Check out, start experimenting, but then when you're ready to build, I would go to this choose your stack. I'm partial to Scaffold ETH and where'd it go? Biddler, which is now Hardhat, because I built Scaffold ETH, and really I just built it on top of a lot of these other things. But Biddler is good. Create ETH app is great. Like really all of these are good. You can get in here. They're just going to have a little bit of differences. Scaffold ETH was built for the brand new developer. I'm looking for that developer that just wants to drop in and have this experience where they can change a few lines of Solidity and get a contract kind of tinker with. Oh, we deployed it. Did this get deployed? Let's see. Okay, we got to close it out. Let's go back. Can we deploy to Berk? I'm gonna go Berkey. Yeah, berkey.surge.sh. Okay, now maybe you guys can go to this app that I deployed. Let's see. Can we actually put in XDAI? The trick was, oh yeah, it's reading it. Okay, so now it's public, now it's working. I think I sent you some XDAI if you want to try it. Let me send some XDAI real quick to this. And we'll see using, so this has been like an hour, but using within the time that we built, you could probably within about a half an hour get to this point where you've built an app, it works right with the smart contract, you've deployed it locally and played with it, then you deploy it to either Ethereum or a testnet or XDAI. XDAI is basically like a testnet with value. Oh, whoa. Oh no, my internet's not loading. Hopefully you can still see me. I don't know why this guy's not working. Anyways, we could send value in and we can interact with it, and that all could happen within that 30-minute window. So if you are a new developer, I totally would suggest that you try out Scaffold ETH. Check out some of those others on that list. Like maybe my tools aren't for you. If you're looking for fundamentals, get in and check out eth.build. And this is really good for just like tinkering and playing around and testing assumptions too. Like what does that call data do? How can I bring in, you know, can I use a mnemonic instead of using a private key? And how does a mnemonic work, right? So mnemonic is basically like a phrase. It's easier to write down and store in your sock drawer, but it's basically a phrase that generates a private key, and you end up kind of doing a hash thing to get that private key. But this is a great tool for playing around and poking around. Any closing questions? Hopefully we've covered everything. Keep an eye out for ETH2, right? The future of Ethereum is bright. They're much smarter people than me are building a new system for Ethereum. Check out ETH2. It's eventually like proof of stake and shards and stuff I don't even understand yet, but I'm excited about. In the near term future, there's stuff like ZK and Optimism, where we're looking at how we can, instead of using a sidechain, we can use some kind of L2 solution that's using signatures. Remember that call data? That call data is actually really cheap if it's not being executed on. It's expensive because basically you're calling a function and it's got to do a whole bunch of execution and change some state, and that's really expensive. But storing call data is actually pretty cheap. So what they figured out is let's put the execution or the possible execution into that call data, and let's write it into a transaction on chain, but let's not execute it. Let's not change storage. Let's not mess with it at all. Let's just leave it there. And then off chain, we'll read it and we'll keep track of all of that stuff. And then if anybody sees it and they want to challenge it, then they can basically, you know, create a fraud proof and submit that. And then that call data then gets read and we have to spend all of our gas. But what's cool about this system is you sort of get this, I only need to execute if something goes wrong or someone needs to prove me wrong. So this is kind of how Optimism works, is now it's doing this layer 2 stuff where it's putting a lot of stuff on chain, but it's not executing or storing anything. It's just putting it there so everyone can see it and prove that it's happened. And you can read from that state. And then if someone does something wrong, then you can come back in and prove that fraud, which means there's going to be like a withdraw period, right? There's some kind of like cool down period. Oh man, there was all sorts of questions in the chat and I didn't get to them. Oh. Uh-oh. I think I may have missed some questions. Oh, cool. Open was founded. Neat. What is a stable coin? Okay, so last thing would be like DAI. Check out DAI. It's a stable coin. Basically, you put in some kind of collateral and you get back some kind of stable coin, and that collateral, as long as it stays underneath the value of the coin. So I'll put in $100 worth of ETH and I'll get back $60 worth of DAI. And as long as the oracle that's telling the contract what the price of USD is and what the price of ETH is, as long as the price of ETH stays above that $100 of ETH stays above that DAI, then I have this stable coin over here that I can use and trade and use in other places. If it ever inverts, right? If I've borrowed more than collateral I put in, then basically it gets liquidated, right? Your ETH is gone. You can keep the DAI, but you get liquidated. And so basically it was a trick to figure out how to create a coin that would stay stable. And I mentioned that was amazing for UX, but it also helped out with DeFi, and a lot of it kind of caused this explosion of DeFi that happened too. I think I answered anything. Anybody have any closing questions? I got to get to bed. Thank you guys for having me. This has been a lot of fun.
So much, Austin. That was really great. I learned so much. And I'm really glad I read up on DeFi before this because I understood most of what you were talking about. So thank you so much.
Thank you for having me. This is a lot of fun. Hopefully we get to do it again sometime.
Yes,
Yeah,
definitely.
thank you so much, man. This was awesome.
Awesome. Great. That's great to hear. Okay, see you guys. Happy Tuesday. It's great to hang out. Hopefully
my
one
God.
day in person.
Yes, let's do that. All right.
Awesome. See you guys. Thank you.